This is Greg Remke with Economic Thinking, and this is part 4 of a presentation on the economics of space exploration. Wanted to focus in this session on teachers, students, and early rocketry. The goal here is to show the history of space exploration, or at least of high altitude rocketry, and show that it's different than we might think. I've mentioned earlier we have resources online, our Economics of Space Exploration study guide, which has a variety of articles on different topics and was prepared for the National High School Debate Topic in 2011. And in this presentation, at the beginning, I'm going to be drawing from an essay called The Sources of Invention by John Jukes. Jukes wrote this article for the Freeman years ago, and it focused on the space program. And while praising the success of NASA and Apollo and the moon landing, was critical of the idea that only central government programs or university programs or big corporate research projects could push advances in modern technology. He focuses on sort of the myth that in the 18th century it was the tinkerers and people working on their own who pushed advances, but that in the 19th century it was that, but in the 20th century and 21st we need to do, technology so big you need big budgets to do it. He says that's not true. Also, we have online notes from different books and movies on space exploration that I would recommend for your entertainment and edification, and also if you're interested in the space exploration debate topic. So, by rocket into interplanetary space. Does space exploration require large-scale government or corporate investment? This is the question that Jukes asks, and he investigates it using empirical research of major scientific advances from the first half of the 20th century. And he finds that in at least a third of the cases or more, major advances were achieved by people working on their own or in small teams, people from interdisciplinary or cross-disciplinary backgrounds, achieving major breakthroughs, in part because they didn't have much money, and in part because they weren't sort of stuck in the views of people already in that field. He mentions, for example, the advances in Kodachrome were achieved by people who were musicians coming into the field with new ideas. So in terms of space, he says, look at the history of advances in high altitude rocketry and the theoretical work that sort of laid the groundwork for later operations. We begin with a Russian schoolmaster, K.E. Zalakowsky, in 1903, who made the first sort of fundamental contributions of the physics of what it would take to get out into space. And then Hermann Oberth, a teacher of mathematics in Transylvania, which is part of modern Romania. His 1928 book, By Rocket into Interplanetary Space, was a major advance on how you'd actually get rockets into space. And he inspired his students. One of his students was Wernher von Braun, who writes about how being in Oberth's classroom at age 17 just got him excited about the idea of going into space. Von Braun and his friends basically started a space club in Germany between the wars, and they are pushing the advances of what it takes to get into space, launching rockets on Saturdays. Unfortunately, and unfortunately for the British, they happened to be in Germany, and the Nazis, when they took over this space club and funded it, and basically got the V2 rocket that was launching the first rockets with bombs landing in London. Now, the end of World War II was sort of a mad race by the Soviet army coming from the east, the US, British, Allied army coming from the west, and one of their goals was to capture the German rocket scientists. We got half of them, the Soviets got half of them, and the space race that we know of in getting into space and landing a man on the moon was much of it driven by the German scientists like Wernher von Braun in the US. So the point here is, yes, governments got into space, got on the moon, but many of the major advances were accomplished by clubs, amateurs, teachers interested in rocketry and space. So rocket transportation, space exploration, we have what you might call a socialist calculation debate. The socialist calculation debate was one where market economists like Mises and Hayek argued that the Soviet Union couldn't work as a centrally planned economy because it didn't have prices. The role of prices was to discover the alternate uses of raw materials. So if you're trying to figure out, whether you should build a new railroad between two cities, go, through the mountains or around the mountains, you could add up all the raw materials you'd use going either way. You could look at the different technologies involved in, blowing things up to get through the mountains or going all the way around it. But in the end, without prices, you can't really know which is the best way to do it, because you can't know the opportunity costs of the raw materials that are used in the project. The market economy, how do we decide which is the best way? Well, which is cheapest, which is the least expensive and leads to the lowest cost transportation when the train line is built. Similarly, getting into space, we don't know which technologies are best. We can't know without prices. So not only do we not know which technologies work best, but it's hard to even compare which approaches are most reasonable without prices. So an example of this is it better to improve airplanes, jets, to get higher and higher and higher like the X-15 and fly directly into space? Or is it better to have a rocket, like a military rocket with solid boosters, and just launch your way into space? Well, it's not clear which is the best approach. If you look at the marvelous movie, The Right Stuff, both the movie and the book, it looks at the Air Force pilots who were experimental pilots who were flying through the speed of sound faster and faster. And all of a sudden, they were completely defunded. Money was pulled from that project and invested in rockets. Now, was that the best technology choice? It's hard to say. The rocket people thought it was, the airplane people didn't. But it led to the astronauts and our successful space program, but we don't know what would have happened if money would have gone into airplanes. What we find now with SpaceX, with Spaceship Company, we find a mix of some companies running rockets like SpaceX and some companies running airplanes like the Spaceship Company. Again, two different ways to get into space. So space planes or rockets, it's hard to know. You can have your scientist who's the advisor to the president, advisors to NASA claiming this is better and that. But sort of the economic argument leads to skepticism on that, in that without prices, without competition, it's hard to know the best way to get into space. Another part of the debate in the space program, early on, getting a man into space, then the question is, what's the next thing to do? Well, the people that knew the space industry said, well, the next step is to get an orbiting space station, get yourself out of the gravity well, and then from there you can develop the technology to fly to the moon. And once you've flown to the moon, much of your same technology can fly you to Mars, because you're already out of the gravity well and much less energy to go from place to place in space. However, the political concern of doing it that way in the 60s and 70s was, well, if we built the space station first and then went to the moon, what if the Russians got to the moon first? What if they flew directly to the moon and got there first? They'd win the space race. Well, as a political Cold War issue, maybe that's a big thing, but in terms of exploring space, who cares who gets to the moon first? Really, it's more a question of who can inexpensively or least expensively develop the safest, most efficient space transportation technology so you can get up into space in the high frontier and begin your exploration. So, in any case, politically, we went to the moon, we landed there, great success. The next step, NASA goes back to the Congress and says, okay, we're ready for the next step. Congress says, what's next? And they say, oh, a space station. Then the question, what do you need a space station for? Well, we're going to develop the space station, then fly to the moon. And Congress says, well, wait a minute, you've already flown to the moon. What's that about? So the challenge is, by what we found is that we got to the moon, but it was so expensive, the government couldn't afford it. Sort of like the ocean explorations of the Quang Ho in China. So, problem. Later on, another set of questions, should we have the space shuttle or a big dumb booster? Boeing and other contractors said, look, we can make a big diesel booster rocket that'll get into space dirt cheap, much cheaper than the Atlas and the other existing rockets. But if we did that, that would undercut the rationale for building the shuttle, which was supposed to be inexpensive because it was reusable. Unfortunately, the shuttle came in way over budget. In terms of space exploration, having inexpensive, reliable booster rockets would have been much better than the shuttle. But politically, we got the shuttle because it could do a bunch of things. And again, NASA is a research and development organization. They're not interested in old technology, they're interested in new technology. Another story is the Space Studies Institute, basically a whole space movement started by a physics professor at Princeton University, Gerard K. O'Neill. He was looking for a way to get his physics students interested in physics. And so he said, okay, let's build a space colony. And the way he taught the course, students needed to understand the physics of orbits and colonies and various things, artificial gravity, to build the colony. Basically, he managed in his Princeton University Physics 103 class to build outer space civilizations to inspire the students as well as teach them physics. Those students went on to build the L5 Society, L5 being the Lagrange zones, and then from that came the Space Studies Institute. So it's an example of the excitement of space exploration sponsoring students, even though it's from a teacher like Zalakowski, Herman Oberth. Teachers were major drivers of space exploration. So now we're getting back out into space with the space station initiatives, the X Prize, billionaires are funding space. We're looking at what are the value drivers in space, either survey data or tourism. I mentioned some movies, Astronaut Farmer, Apollo 13, The Right Stuff, Space Cowboys, Everyone Space. These are nice movies and documentaries. Links to those are on our website. For debaters, public school students were debating about mining on the moon, getting helium-3, I think. And so debaters looking at that top will look at moon mining operations as a reason to explore in space. Another is asteroid mining. This is a big deal now with the recent near strikes of asteroids. So astronaut mining, the claim is there's a lot of valuable resources out there. There's companies doing this, and we might have the technology to, stop a comet or asteroid coming toward the Earth, or at least, as I tell the students, at least we can shift it maybe over to land in Canada instead of the U.S. There's a nice video by Bill Witter on the free frontier, arguing for free enterprise in space. And one more idea about space exploration, moonzoo.org and Space Zoo are websites that that are focused on students doing space exploration. Middle school students, high school students could be the next frontier in space exploration. Of course, many of us would like to launch middle school students into space. They tend to be they can be irritating sometimes. However, what they're getting at with moonzoo is that we're taking tons of pictures of space and nobody's looking at them. No computer can see important things the way people can. So you can go to the moonzoo website and volunteer, and you can be surveying these pictures of the moon and Space Zoo pictures of space. And when you see certain anomalies that they train you to look for, you report that back, and then scientists can explore what it is you found. So we might have found all sorts of amazing things in space. They're sitting in a photograph someplace that nobody's looked at. Okay, thank you very much for parts 1, 2, 3, and 4 for my Economics of Space Exploration talk. Hope this has been fun, and if you have questions, please send me an email. Thank you.